all. Thank you, the panelists, for very insightful presentations. We have a little less than what I had hoped for left in the session for Q&A. I'd like to open that to the audience, and does anybody have any questions for our panelists? Yes.
So my question is for Dr. Mohabi, primarily, but anyone can answer it, I guess. So you spoke about 5G connecting a whole lot of different protocols, including Bluetooth or Bluetooth low energy. But if I have one of those, I guess, dumb devices that's very, very low energy and you can only transmit maybe up to about 1 meter, how does that connect to 5G? You know, I mean, today I can think of it connecting to my cell phone, and then from there it'll go up to the cloud. But is it supposed to look different in 5G?
So, go ahead, please.
Yes, so one of the requirements of 5G was actually to decouple the radio or the access technology from the core network, so that you can connect any access technology with it, whether it's wireless or light or cable, tethered cable, Ethernet, to a core which takes care of your mobility, security, everything, your identity and all that. Now, that requirement, I've seen it in ITU, but I haven't seen it implemented in the 3GPP systems. The 3GPP pretty much is LTE, which, on a steroid, if you like. But we have to wait and see what happens by 2020. There's still a lot of discussions going on. Now, what would happen is that it's simply you're connected to the network. I mean, the wireless is the last mile, the light is the last meter, if you like. And then from there, for IoT, you have to be connected to the core network somehow. It could be wireless backhaul, it could be wireline backhaul, but you need that backhaul. But in general, I can tell you that the cells are getting smaller and smaller. This is happening in the industry. A small cell is happening now. I think other people are working on femto cells and personal. There is a company called, I can't remember the name of it, but they have a P cell. It's called a personal cell. So that's the trend, and this is what would happen. I personally think Wi-Fi will come from the personal side, and cellular will come from the public side, and somehow in the middle they meet each other.
Thank you. Anyone else? Yes.
Yeah, I have a general question on the visual light localization. Would you envision that what's the biggest problem, what's the biggest challenge of the large-scale deployment of the visual light localization or visual light communication?
I understood that your question is about the challenge of deployment?
Yeah, I mean the biggest challenge of large-scale deployment of the visual light localization, because currently the technique is not very mature, so maybe next 5 years or 10 years it can become much better, so we can consider to large-scale deployment.
One of the challenges to large scale has to do with the fact that you need a lighting system that can support this. So typically what you get is not like you can add a beacon here or a access point there. Typically it involves updating the lighting system. And that takes time. And if you see what the replacement cycle is for light being replaced, for that, then it depends a little bit but it's at least many years. So if you already have your new fluorescent lights did that last year or 2 years ago, then you're not going to replace it immediately. So that's one thing. The other thing is that we find that this whole thing about indoor positioning and indoor location, that a lot of parties are still learning what to do with it, how to turn it into something that is relevant for you as a shopper or an office user or an industry or whatever. So it is both from an application point of view that the whole domain of indoor positioning is relatively new, as well as that the rollout of the infrastructure requires this cycle of replacing the light. The fortunate thing is that we as Philips Lighting are in the business of selling these kind of lighting systems. So what you see is that we have quite a number now that have a pilot installation, are trying it out, while at the same time we can already replace their lighting. So once the application is in place, they can scale up.
Thank you. Any others? Yes, please.
See, that's 5G are going to replace really Wi-Fi. What is your comment on that?
5G replacing what again?
Wi-Fi.
Okay, so the question is 5G going to replace Wi-Fi?
That's an interesting question.
Dr. Ling.
So I think 5G will not really, just my view, 5G won't really replace any existing technology by itself. So Wi-Fi itself is evolving to be part of 5G, that's my understanding. So I was involved in the 11AX standardization. I know that they are talking extensively on how to basically get a piece out of the 5G. So I think 3GPP is doing the similar thing. So everybody is rushing to 5G. 5G is not really specific to any particular technology. But I would say all the existing technology, especially Wi-Fi, cellular, they're all going to play a very critical role in 5G. None of them will be replaced or what. So, and they will all be very important.
Dr. Moon.
Chime in. I hope it doesn't, and I'll tell you why. Because 5G is still in the domain of commercial operators. And if they grab, it's a land grab, if they grab the unlicensed band, the spectrum, which there is a lot of it there, and there's going to be more coming, then really, in a way, you end up paying for using even the most rudimentary things that you take for granted today, which is basic connectivity. So hopefully Wi-Fi will survive, and it would stay in the domain of public. It becomes like our property, not the property of one corporation to make money out of it. And if that happens, unfortunately, I think it's a step back if we lose that, if we lose Wi-Fi.
Yes.
Okay, so having heard that comment about the operators, let me ask the panel what they thought happened in 4G. So in 4G, if you look at it, the operators actually lost all the revenue. They had to build the networks, but really what happened was that most of the monetization went to the internet giants. And so as we do that trend towards this next era of 2020 beyond, some people call it 5G, I don't know what it's going to be called, but we'll see an increasing transformation on connectivity. How we connect in the next decade is going to change. It's already changing right now. You see the world of open sourcing and open communities. So you're right. Actually, you just didn't know is we made that comment with that. Is how we're going to efficiently connect. So I'd like to go back to Dr. Dingrate and ask him, because he put up a good slide on meshing and ad hocing, but how do you think the present protocols have to evolve to have an efficient throughput in order to support those meshing and ad hoc, so that we can get the connectivities at the edge of the network? If you could answer that, would be great.
All right, that's a big question. So let me try to answer at least part of that. So as you can see that it's so fragmented market, everybody is like pushing their own standard, and eventually my view of 5G or whatever you call it, it's going to be a combination of all this. So all the things has to be connected. Not all of them need to have like high speed, but at least they are getting to the core network. So you're fine. So connectivity will be a big topic for IoT, but it won't be the only topic. So once you are in the network, you're done with the connectivity, but there are more things coming with it. So in terms of business, I think you can make money on both sides. It's not about operator losing money or making most of the money. It's about, hey, IoT devices providers, they're gonna make some money out of their innovative IoT solution on the IoT's like customer end. And also the IoT providers, it's not just connectivity providers. It's not about like carrier providers. It's about like cloud providers. All the AWS, Microsoft, they're providing all the IoT cloud services, ignoring the connectivity. They're assuming all the connectivity is there. It's actually already there for the most part. So let's worry about once you get IoT stuff into your server, how are we gonna deal with those? You can actually make tons of money on the cloud side also. So everybody is trying, I would say everybody will get a piece of this. But there's nobody really getting a whole bunch of this. Let's work all together and make this thing happen. I don't have a clear answer for it because if I have, I'm gonna make billions of dollars out of this already. All right.
Any other?
I can address the first part,
Yes, please.
who's going to make money out of it. You know, industry moves on. You know, we don't wear coal as much as we used to, and connectivity is the same. We don't use the big telcos as much as we used to, right? And future, we don't need a bottleneck where people, you know, are, you know, strangling the, if you like, e-commerce and the progress. So they have to find other ways. Like you don't have pots anymore. You don't have the telephones anymore in the house. You're probably using the mobile. They will make money some other way. The business model has to change and adapt.
Thank you. Any other questions? Yes.
I have several questions from Ms. Jensen. You know, how long the effective communication, light communication could be, since we know that light has a strong scattering property. It's effectively using the laser.
So is the question what the range of the
Yeah, it's-
light communication through LED is expected to be?
Actually, it depends on, so the examples I gave with using a camera, it depends on having sufficient pixels exposed to the light to be able to extract the data. However, and then you're talking, let's say then you're talking in a typical case like this, you're talking about maybe 5, 6, 7 meters. But if you go to a photodiode, then actually the range can be much larger because the dynamic range of the photodiode can be quite different. So we have done experiments where simply with a photodiode and a small light point, we cover around 50 meters comfortably. So it depends on the application, it depends on, let's say, your transmitter-receiver combi that you choose for that application.
Those in the natural light, like the light from this light, can also affect the communication range with light.
The natural light is considered, it's a signal-to-noise story, and the modulated light versus the natural light. Natural light is you can call it DC, so you can extract you can separate the modulated part from the ambient light. It just raises the threshold where you see the modulation. And of course, there's a point, just like with every other technology as well, that you can saturate your receiver with enough other signals so that the interference is too much. But typically natural light is not an issue because it is DC, so you can extract it on the receiver side.
Thank you.
Yes, please.
I've got a question to the panel on the role of edge or fog computing. I think all 4 presentations have focused on the connectivity aspects in various ways. But due to the sort of emergence of big data coming from sensors and so on, is the model likely to remain processing in the cloud, as Dr. Ganding mentioned, or do you foresee a future where you have processing sort of outside the cloud, outside the servers, closer to the front end, and how would that sort of figure in the network topologies that you have described, either in 5G or mesh networks or even in light communications?
Right. I know mobile edge computing is a big factor going into 5G, but I'll let Dr. Mojave answer that one.
So really for these things to happen, you have to remove any bottlenecks which connectivity could cause. If you want to do computing in the cloud or on the edge, then you really don't have to think about connectivity. It has to be there, it has to be low latency, the bandwidth has to be sufficient, and it has to be reliable. Right? If you have these things, then you can't have, I've seen people play games now, in the cloud, which is really, it requires all those three requirements. But, what market decides, what application decides, I have seen this paradigm or paradox that, we keep going from lump to distributed, from distributed back to lump, right? And this has been happening. When I started, there was a Cray computer in the university and an AMDAL, and we used to work, and that was cloud computing, right? We all had the terminal, and everybody went away from that. We went to personal computers, which became distributed, and now we're going back to that again. So, and I'm sure this cycle will continue.
And maybe also from another perspective, there's also the thing about reliability and security, and sometimes even privacy that influences this. Take one example, if you put a presence sensor, just an IR sensor in this room, so that the light goes on when somebody walks in, and when there's nobody there, it switches off, then you can do that through the cloud. But actually typically you don't want your light switch to be dependent on that connectivity. And actually I've seen now all kinds of sensors that are using microphones or using cameras, where actually from a privacy point of view, you don't want the raw data to just go over the network into the cloud. But you want just the fact that there is 60 people in this room to go there. So those kind of trade-offs will always play a role besides the connectivity into the application trade-offs of what information is communicated and what is processed locally.
Thank you. Any other questions? I think we're over time. If nothing else, I'd like to thank our panelists for sharing their insights with us.